All right, today's day 5 of vectors, and now we take vectors and we give them starting points. So in the past, we said it doesn't matter if the vector's here and going that direction. It could be here, 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 and they were all the same. But now we need a way to say, because obviously there is a difference between it being here and it being there. There's a difference. It's the same vector, but it's in a different place. How can we control its place? We got to know how far over and up the thing goes. Let's say it goes over 4 and up 1. Okay. Then if I want to force it to be in a certain spot, I got to write the vector differently. Because if all I have is 4, 1, then all I know is its direction, and I can tell its length, but I can't tell where it is. So what you do is you say, I want it to start here at, let's say, 2, 1, and that's like a point 2, 1. And I want it to go up by sets of over 4. Again, that's what it looked like, right? Over 4 and up 1. And then I'm going to put an x and a y in front of this whole thing to make it an equation, and there it is. Now, I don't expect you to be like, oh, I understand everything now. But that's a different way to write a vector. But it's still kind of got some vectorish things about it. This still means go over 4 in the I direction, and then 1 in the j direction. But it's got a starting point. You can tell from this way of writing a vector where it is. The other way, you can't. If I just say 4, 1, it's a vector, but it is assumed, just because it's easier, that its tail's at 0, 0. But really, you could put it anywhere. This forces you to put it at 2, 1 as a starting point. So again, this vector would look like this. I go over 2 and up 1, I put a dot. And then starting there, I go over 4 and up 1, and then my vector is now there. I moved it from its original spot, which would have been at 0, 0, and moved it up there. All right, so let's say I gave you this equation. xy is 4, 5 plus lambda 1, 1. I'd like you to try to draw that. Just sketch it. Sketch what it looks like. You know where it starts, and you know where it goes. The common mistake is people think it starts here and then ends here. That is not what happens. It starts here, and then it goes this far. That's true. Okay, did you say over 4, up 5 is where it starts? And then it goes over 1 and up 1, and therefore it's like that? Raise your hand if you had that one right. Okay, good. I think you're catching on pretty quick. All right, now, what if I gave you a starting point and an ending point, but didn't tell you how far it went? Couldn't you figure out how far it went if I told you the starting point and the ending point? So I want you to make me an equation just like that. I'll leave it up there. But I'm going to this time tell you, instead of starting at 4, 5, this guy is going to start at 2, 1. And it's going to end, the head end will be at 5, negative 2. That's a vector. Write me the equation for it. I'm going to pause for a moment while you guys try to figure this out. All right, here's how you should have done this. First of all, if it starts at 4, 5 and goes here, that was a completely different one than this. But the start's still the same. You're going to have an x and a y. Notice that was kind of generic. And then you're going to have a 2, 1 as your starting point. That's pretty easy, just to copy it from above. plus a lambda. That's also easy to copy from above. But then what's the one part I made you think on? That distance, how far it goes, okay? And how far did it go when it went from 2 to 5? You could say it went 3, or you could have taken the head end minus the tail end. Do you remember that? Could have gone 5 minus 2, 3, and negative 2 minus 1, negative 3. Does that make sense? All right, so if I give you one of these equations, and I don't say anything about it, I just say xy and 1, negative 3, plus lambda 2, negative 4, you should be able to say, okay, I know where it starts. I know how far it goes. Shouldn't you be able to figure out where it ends? Figure it out. I'll pause for a moment. If you start here, and I said you don't end there, where do you end? Okay. It's fairly simple. I know some of you didn't even use lambda for this, but I want you to think about lambda for just a second. If I say lambda is 0, it's like you're going to take 0 vectors in that direction. So it's like I'm telling a computer, like start at 1, negative 3, and then go 0 of these, which would mean you don't go anywhere. So if they put in lambda as 0, you just have your starting place. So then what do you think you're doing with lambda to get the head end? I'm putting in a 1. You're saying I want you to go 1 vector length and see where you will be. And it goes 1 plus 1 times 2, which is 3. And it'll get to 3, and that's where it'll stop, in that direction. And then it'll go negative 3 plus 1 times negative 4, which makes negative 7, and that should have been the head end. Raise your hand if you had that right. Okay, I think you're getting it. Now, does this equation look a little bit like parametric to you? Do you remember what parametrics were like? They had an x equals equation and a y equals equation. Know what I'm talking about? I bet you can do it without even me showing you. Write a parametric for this. I'm going to pause. This vector can be written with a parametric now. So let's see how you did. I think you probably figured out the x equation really easy by just looking across here and said 1 plus 2 lambda, or lambda 2 would have been fine. Raise your hand if you had that one right. Now, did you switch it to t? All right, you could have or you could not have, and I'd have been okay. I'll accept either one. If you leave it in lambda form, then you're kind of showing the person that's reading your parametric that you came from vectors to get there. Do you get what I'm saying? Because the vectors are going to always have that lambda. They use that as the standard for a vector. All right, so if you left the lambda in there, that's fine. If you switched it to t, I don't think that's bad. I think that's good that you know that parametrics usually have a t. All right, y equals negative 3 plus negative 4 lambda. All right, but always remember that parametrics have to have a limiter. T has to be between what and what, or in this case, lambda. I'm going to use lambda since that's what's in my equation. What you don't want to do is introduce a new variable. If you use lambda, then you better say lambda. Okay, and lambda has to be between what and what? Well, it's not that complicated. It's between 0 and 1. How do I know that for sure? Is it just always going to be that way? I want to think it through and go, if I put in a 0, that means I will start at this point, and that's where I want to start, right? And if I want my vector to end at the head end, then I want to just go 1 vector length. Okay, it's like a counter of how many vector lengths do you want to go. So if I put in a 1, then it's going to make the tail end, and it goes where I want it to go. Because again, this is a vector. It's supposed to go from here to there and stop. In this one, without the limit, it would go forever. And that's not making it the same thing. So we need that domain in there. All right, you have now changed it to parametric, and that seems pretty cool. You've just changed it from vector form, which you didn't even know before, to parametric form. And now take a guess how it gets harder. Changing it to what's the other form? Not polar, although that does exist, but rectangular. The only thing is, there's another name for rectangular. It's just rectangular. It uses x's and y's. But all along, we could have been calling that Cartesian. Have you ever heard of that before? Okay. And rectangular and Cartesian are the same thing, but just know in the directions for your homework and maybe on the test. If it says Cartesian, that just means x's and y's. Do you get that this has x's and y's and lambdas? So we got to get the lambdas out of there. So just like before, it's just like last unit where we take a parametric and get the lambdas or the t's out of it. Get it so it's only got x's and y's. I will pause while you try that one. Okay, so there's really nothing new here. It's just a review test question. Like you've done this before. You had to solve it then for lambda. So I'm going to subtract 1 from both sides. I have x minus 1, and then I'm going to divide it by 2. Did you get x minus 1 over 2? Okay. And then the reason I'm about to tell you this next part, remember how we would then usually, since lambda is this, we'd go stick it in for lambda? But you could do that, and it would work. But there's going to be ones with x and y and z, isn't there? So do you do not want to have to try to put this in multiple different ways. So if I were you, here's what I'd do. I'd just solve both of them for lambda. This would be y plus 3 over negative 4 is equal to lambda. And set this one equal to this one, because then when there's a z equation, you can just, let's say there was a z equals negative 2 plus lambda or whatever. Then I can solve that one for lambda, and it would be z plus 2. And there'll be 3 of them, and you just set them all equal to each other. Let me show you what I mean. Let's say we have this point. X, Y, Z is going to start at 1, 2, 3. Okay, and it's going to go, this is where it goes to, negative 1, 0, 4. Now, that's a vector going from a starting point of 1, 2, 3. Let's visualize it in the room. Over 1, up 2, back 3 feet. It's about, it's pretty close to where this is. Okay? So it's going to start there, and it's going to go down 1. No, first it's over, sorry. Over 1 to the left, up 0, and 4 more forward. So it's going to go to here. Okay, so that's what I'm asking, this vector is asking me to do. All right? First, the easy part, right, is parametric. Then, the harder part, solve each of them for lambda so that you can get it in only x's and y's. And your answer will look like a fraction equals another fraction equals another fraction. But it'll only have x's and y's, and z's, sorry, in it. Because now we have an x and a y and a z. All right, I'm going to pause while you try that. Now I'm going to translate, and I'm going to solve for lambda. And I actually can do that, but I'm going to leave it as a fraction right this second. Then is my minus 2. And wait a minute. There is no lambda on that one. What did you guys do on that? You just left it? All right. Now I want you to think that through for a second. What that means is if there's 0 lambdas, equaling y minus 2, then y is just always going to be 2, right? Okay, it doesn't matter what lambda is, y is always 2. So y equals 2 is a truth, but it's not telling us what lambda is. We'll deal with that in a second. And then I'm going to deal with this last one, z minus 3 over 4. And I could set this one equal to that one for sure. It's supposed to be a minus, z minus 3. That one is equal to that one, but if we don't have the y component, is that going to be a problem? If we have a rectangular equation that doesn't have any y, that would be a problem, wouldn't it? All right. So in this case, we will just need two separate equations. This one is equal to this one because they're both equal to lambda, right? Okay, so I'm going to say x minus 1 over negative 1, which, by the way, when you divide by negative 1, did you know that it switches it around? Instead of x minus 1, it's 1 minus x. And that's equal to the other one, z minus 3 over 4. And where's the y equals thing? Well, it's y equals 2. That took a little extra thinking. Because I need the y, otherwise I can't just like act like there is no y. Y is always 2. And it's okay to have two separate equations. In fact, if I'd have written this, if this had had its own little fraction, I would have had this equals that, which is two equations anyway. So it's okay to have multiple equations. It's just that your equations can only have x and y and z in them. So there we go. Okay, so that's about as tricky as they get for the new stuff for today. I'm going to show you where it is, and then you're going to take a little in-class quiz. But I think you're going to say, this stuff, that was easy. Almost everybody last hour got them all right. So I'm going to pause a second. It's this one. Okay, so to start with, they give you a point and a vector, and they want it in all three forms. That's what we just did. Okay, if I were you, I'd start in vector form, and I'd start with x, y. Let's do this one together. Equals, and then, now what? 5, negative 6. That's a point. It's important to get that that's actually, this part right here is not really a vector. That's a starting point. And then plus lambda, and then 5, negative 3. There we go. Now parametric form for it. Remember, when you have your parametric form to include your lambda restriction, don't forget, lambda is between what and what? 0 and 1. Good. And then Cartesian form is just a fancy way to say rectangular form. And it's just that it's got an x and a y and a z. So you can have two equations if you need to, but this should only have x's and y's and z's. You got to get the lambda or the t out of there. All right, so a couple of those on the front page here. All right, so it's just two practices of it. This one's got a point and another point. That's the kind where you have to figure out what are the steps. Like this one tells you the steps. You go this 5 to the right and down 3. This one, you got to figure out what your place, your directions to go to. This is your start. This is the directions on where to go next. And it's not the final point. So if I were you, I would start the equation, then remember that is not what goes in there, and then figure out that it's the head end minus the tail end always. All right, moving on. There's this one. And what's different about this is just that they say A equals, okay, so that's just our starting point of our vector. So this is exactly the same, and so I don't think we need to do two of them. Why don't we just get rid of the second one? Okay. And then let's move on to this kind. This is exactly the same as the other slide, so we don't need to do this at all. This one this one's got an x and a y equation, so it's giving me a parametric. Can you back it up then and make it into a vector equation? Sure you can. If you can make something from a vector into a parametric, you should be able to take it from a parametric and kind of go backwards and make it a vector equation. All right? These, notice, it says 0.5 minutes. That means it's not supposed to be super hard. It's supposed to be actually really easy. Okay? So it shouldn't, that is, I know sometimes those are misleading, but it's trying to say that this is not supposed to be hard. Okay, last thing. Everybody look at this, and I'm only going to do one of these. On problem 5, when it says r equals, we've never had that before. What was normally there? X and y, and you can just act like it is. Act like there is an x and a y there. It's just okay for them to call it r when they're defining what this is. They're saying r is this equation. It's kind of like we sometimes would name them z, and sometimes we'd name them p. They've named it r, but there's an xy out there. Okay, I don't need you to do that one. And I think that's enough. If you go through number 5, first part, it's enough for today. Okay, that's all I got for you for the video for today. We're going to take a little in-class quiz now.